వెల్కమ్ బ్యాక్ టు ఈ క్లాసెస్. ఈనాటి మ్యాథమెటిక్స్ 2A పేపర్లోని మ్యాట్రిసెస్ టాపిక్కు సంబంధించి షార్ట్ ఆన్సర్స్, వెరీ షార్ట్ ఆన్సర్స్ గురించి ఇప్పుడు తెలుసుకుందాం.
I am considering another example. If A is equal to 3, 4, 1, 3 minus 4, 1 minus 1. They given like this. 3 minus 4, 1 minus 1. Then show that, you have to show that this part. Actually in this question, by seeing this, you may tell the one of the first year concept. Show that a power n is equal to, but to prove that a power n is like this, 1 plus 2n minus 4n, again n, 1 minus 2n. This is the part. For all n belongs to n, n is natural number set. For all n belongs to n, or they may say for all positive integers. Positive integers means greater than 0, not equal to 0. First you remember that part. So for all n belongs to n, so that's why it belongs to like this. Right, a is this much, a power n is this much. So when you have like this, you have to prove this part. This is the basic thing. A power n is given. So that I have to prove it. Here while I am giving the proof of this one, this can be proved by using mathematical induction. You write this statement. This problem can be solved. This problem can be solved. This problem can be solved. Can we solve by using mathematical induction? Mathematical induction. You remember that part. So we are applying the first year concept. Almost all we may forgot. This problem can we solve by using the mathematical induction. Okay, I am recollecting what is the process of induction and how we can apply the induction. Induction is a process to prove the statements. First part, you remember. Again, while proving these inductions, we may apply. First we consider n is equal to 1, and then we assume for n is equal to k, and then we can prove for n is equal to k plus 1. So this is an approach to prove A by using a mathematical induction. Right, I can prove by using this mathematical induction in this one. Let us suppose n is equal to 1. My aim is to prove that for n is equal to 1. If n equal to 1, a power n will becomes a power 1. That means this is equal to, wherever n you put the n as 1, that means a power n is already 1 plus 2n. So 1 plus 2 into 1, again minus 4 into 1, again 1, again 1 minus 2 into 1. So this is the part. This I can write 1 plus 2 minus 4, 1, 1 minus 2. That I may write like this, 3 minus 4, 1 minus 1. You see this, a power 1, it is equivalent to a only. So this is equal to a. So by induction process, if n is 1, the statement will be satisfied. Why? Because a power n is equal to a power 1. Where n equal to 1, a power n will become a power 1. At that stage, that is equivalent to a. Right, it is coincide with a. A is already given as 3 minus 4, 1 minus 1. Based on that, it is coincide with a. So that's why we can say now it is true for n is equal to 1. Hence we can say the given statement is true for n is equal to 1. Given statement is true for n is equal to 1. That's it. That's okay. Now we assume like this. We assume it is an assumption. Assume the statement is true for n is equal to k. True for n is equal to k. Almost majority of the students they won't write the statements, but they may think in brain. But while evaluating the question paper, the evaluator always needs all the steps. For every step we have the marks. If we won't write any of the statement, then we lose the marks. We are the victims. So try to be focused on the every statement also. Why? Because whenever you require, you write the statement like this. We assume that must be what right. If you feel we assume that they know mathematical induction, they know or not, it's not the question. Whether you know it or not, you have to focus on that. So that's why we assume the statement is true for n is equal to k. We are assuming that. Right. We assumed it and we are proving it. N is equal to k. That implies a power k is equal to, we may write 1 plus 2k minus 4k, k 1 minus 2k. It is the part. 1 plus 2k minus 4k, k 1 minus 2k. We assumed for n is equal to k. Right. The next step is, our aim is to prove it is true for n is equal to k plus 1. It is true for n is equal to k plus 1. Our aim is to prove that the statement is true. Now to prove the statement is true for